Now I talked about that earlier. I mentioned that why would we want to use function notation when we could just say y instead of f of x or g of x? Why would we want to have function notation? And this is why. It allows us to look at what happens when we do two processes or multiple processes instead of just one, when we insert one function into another. It allows us to have a way of expressing that without having to get really complicated, give a very complicated verbal explanation. So first of all, let's say that we have three functions. F of x equals x squared, g of x equals x plus 3, and h of x equals the square root of x. And we want to combine these together in different ways. So the first we see f of g of negative 1, and I put this in the box so you'd know how to read this, f of g of negative 1. So we're saying we're going to take the function, we're going to put negative 1 into the g function, and then we're going to take the answer to that and put it inside the f function. So just like anything, when you're evaluating an expression in algebra, you learned that you would start with the innermost set of parentheses and kind of work your way out to evaluate a function. It's the same thing here. We're going to start with what's inside. So we're going to see what is g of negative 1. So that means that we use negative 1 as an input into the g function here. So we're going to say negative 1 plus 3 is 2. So g of negative 1 equals 2. That's our output value. So that means if g of negative 1 is equal to 2, then we can just replace g of negative 1 with 2. So we say now f of 2. So the output of the g function becomes the input into the f function. Now we're going to put 2 as our input value into our f function. Our f function here is f of x equals x squared, so we're going to make this 2 squared, which is 4. So f of g of negative 1 is equal to 4. Now the next one is very similar. It's just slightly different notation. This little circle here means of. So we read this h of g of negative 5. So this actually means exactly the same thing as h of g of negative 5. It's just another way to write it. I tend to see this notation in college level books more, so I wanted you to be familiar with it, but they mean exactly the same thing. So once again, we're going to start with the innermost function. We're going to substitute negative 5 as our input into the g function. So we have negative 5 plus 3 equals negative 2. Now that means we can take negative 2 and replace g of negative 5 with that into the h function. So now we have h of negative 2, and if we look at our h function, we see that our h function is the square root of x, so it's the square root of our input value, the square root of negative 2. Now hopefully you remember that taking the square root of a negative number is problematic. You might recall that the square root of negative 1 is an imaginary number called I. So when we have the square root of negative 2, it's the square root of 2 times the square root of negative 1, in other words, the square root of 2i. However, for our purposes right now, we are going to say that there's just no real number answer to this. So when we say h of g of negative 5, we say that it is undefined in the real number system, or it doesn't exist in the real number system. So we could just say no real number. You could also tell me the imaginary number if you wanted to. But if I say in the real number system, is there a value for that? No. And you would not be able to plot a point on the graph for that because we can't plot imaginary numbers on a real number graph. Now the next two are very similar, except there's not a specific number in them. So something like this, we would read this as g of f of x. So f of x is the input into the g function. We're going to insert the entire function. So we see up here that f of x equals x squared. So we're going to take x squared and substitute it for f of x. So we're going to say g of x squared. So that means that x squared is now the input into the x function. Now this is a little confusing because how can we substitute x squared for x? What we need to do is think of it as this x represents an input value. And now my input value, instead of just being x, is x squared. So I am replacing x with x squared. So whereas this says take x and add 3 to it, now we're saying, and where this said take -1 and add 3 to it, now we're saying this is take x squared and add 3 to it. So this just tells me add 3 to whatever is inside this set of parentheses. Now, same thing here, we have h of g of x. G of x is x plus 3. So we're saying now h of x plus 3. So we're saying the h of x function says take the square root of my input. My input is now x plus 3. So take the square root of x plus 3. So my function now says take my input x plus 3 and then take the square root of it. So these are showing kind of a double process. G of f of x tells us to square x, g of x tells us to add 3 to x, so now we're just doing both. We're squaring it and then adding 3. G of x tells us to add 3, h of x tells us to take the square root, so we're adding 3 and then taking the square root. So it does matter what order these are in. If I switched the order around and did it like this, if I did g of h of x, that would be the same thing as taking g of the square root of x. In other words, take the square root of x and add 3. So in this case, the plus 3 would be outside the square root because what I did first was the inner function, which is the square root, and then the second thing was the outer function, which was add 3.